Hi. So today we want to see how we can interact with the Ethereum network, see the transactions and then get the information that we want. This is the continuation of the Web3 series. So you can go back to the previous video if you want. Here I want to show you a part of the Ethereum ecosystem who is responsible for a large amount of transactions and also big amounts of money. So here we see the transactions for a token on Ethereum network, which is called the Bone. You see it has a good community trust level. But what I want to show you here are these three transactions. Let me freeze the screen so it won't move. This is the first transaction who's buying around 12 Ethereum worth of the Bone token. Now we have the second one who's buying 150 Ethereum worth of the Bone token. And finally the same person who has done the first transaction and bought around 12 Ethereum worth of the Bone token is selling back all of their tokens. But now what they have got back for selling the amount is around 12.5 Ethereum. Here you see the addresses of the first and the third one are the same, so it's the same person. And this person has made around 0.7 Ethereum in only 1 second, which is a good sum of money. Where does this money come from? It comes out of the pocket of the person who has done the second transaction because the first transaction has increased the price for him. This is called sandwiching a transaction or front running. So in this case, the person who's making the first and the third transaction, who is the front runner, knows already that someone's going to buy a lot of tokens. And then with a special technique, this person managed to buy just before the big transaction and sell back right after it. In this series, I will show you how you can do something like that, and maybe in the future video I will also show you the performance of the code that I've written for a similar functionality. Just out of curiosity, let's check the transaction details. So this is the person who made the transaction or asked for it. And you see there is not much money inside his account. But this account has made a smart contract do the front running for them. And even this smart contract you see here, it does not have much more than 4 Ethereums inside the wallet. And now we have our second question. How does this contract who has only around 4 Ethereums make a transaction of around 12 Ethereums? Here is another subject. This is a flash loan. So flash loans enable us to loan big sums of money for a very short time. Within the same second or the same transaction, we have to do our things and then return the money plus small profit. Otherwise, the whole transaction will be cancelled and we end up only paying for the transaction fee. Alright, let's start coding. Just like before, let's import Web3 first. Now we define our main function, which is an asynchronous function. As you saw already, an asynchronous function is a function that does some kind of communication with a web server or a network, or somehow needs some time to finish their job. This is why we always use the keyword of await before running this kind of functions. So when coding here, we will try to avoid problems and bugs by using console.log and outputting the state of our program every time. The instance of Web3 that we are going to create here is a Web3 socket connection. And then we need to give the address of a node who provides WebSocket services. So Ethereum nodes are computers who validate transactions, and they just check that the signatures are correct, the transaction data are fine, but they are different from miners. Miners are computers who do the block hash calculation, which are enormous calculations, by the way. A computer can be both a node and a miner, but the important function of a node here for us is providing a pool where we can access information regarding all incoming transactions. Once a transaction is validated by a node and sent to the pool, miners will come and pick up the transactions they want, which is usually based on the strategies that they have for maximizing their profits and choosing the ones that give them the highest profit. And then with the ones that they've chosen, they will create a block. So to do well a code or a bot who does front running or arbitrage, you will need some knowledge of smart contracts, also Web3 and JavaScript, and even some finance. You will need some finance because you want to know beforehand what will happen to the price when you do a big transaction. Is it worth entering or not? At least you will need to know automated market making strategies. I will try to explain whatever subject comes up and make it clear, but each of these fields will need deep investigations. So this person who has done the front running is for sure using a node, but I guess he's really sitting on the node, or is the node itself, or at least has a node running next to it. And this is the way they can be really fast in seeing the incoming transactions. After that, they pay high fees for their first transactions to make it an incentive for the miners to pick up their transaction before the big one that's coming. There are several websites who provide node services. QuickNode.com is one of the good ones. So on the first page you can create a free account, then you can come to the pricing page. Choose the free one, and then here you have the limit of 10 million requests per account and 20 requests per second. Then you have different networks from which you can choose. I will choose the Ethereum. Then I choose the main net. The other ones are the test nets. Now we create our API. So here the endpoint gives you two possibilities, HTTP provider and WebSockets. I will copy the address of the WebSocket and go back to our coding. So now we have our Web3 instance set up. So to communicate with the WebSocket server, we create a subscription, and this subscription creates a tunnel. This tunnel persists between us and the server. So whenever there's something going on the server side and he wants to inform us, it will send a message through this tunnel and vice versa from our side. So this is how it's different from a normal HTTP request. So we define our subscription as WebSocket.eth.subscribe, and the kind of transaction that we want to subscribe to is pending transactions, the ones that are waiting to be mined. And let's confirm being connected to the socket server here. Now we're connected to our WebSocket server, and then we'll wait for the incoming transactions. To do that, we write await subscription point on data, and when we receive the data of this pending transaction, we have to define another asynchronous function here, which will get the hash of this transaction as an input. And then we can do whatever we want with this data. At the first step, let's just log this one out in the console and make sure it works well. Okay, so I need to add an S at the end of the pending transactions here. And yeah, there you go. It's working, and you see the speed and amount of the transactions that are coming. We can create a link for this hash to be able to directly check them on etherscan.io. Alright, now we have the link. If we click, we'll be able to see the transaction information. You see it's a pending transaction as we expected and has not been mined yet. Alright, so we are sure that it's working fine. The next step is to get data of this transaction or more details on it. We define a transaction as equal to Web3.eth.getTransaction, and for this function we pass the transaction hash that we as the input data. So a hash is like an ID which is unique to each transaction over the network. And this getTransaction function will get the hash and then search over the blockchain to get more details on this and return it for us. Now we log the transaction in the console to see what kind of data we get. So each of these blocks is one transaction, and here you see a big one. And each of these transactions has some data inside. And here block hash and block numbers are not available because their transaction is not mined yet. The important one here is from, which is the address who asked for this transaction. Then we have the maximum amount of gas that this person is willing to pay for doing this transaction, and also the gas price, which is the amount that is willing to pay for each unit of gas. And this max priority fee per gas is the bribe or the incentive that you're willing to pay to the miner to quickly pick up your transaction and include it in a block and mine it. This is another hint to the techniques that the front-running smart contracts use to increase their chances of success. Then you have the hash of the transaction, and you also have the input, which is the data which is passed to the smart contract who will be running the transaction. And 2 here is the wallet or the smart contract which is receiving the transaction or the target for this transaction. The transaction value is the amount of money that we are sending along with the transaction. So all these numbers for gas price and value are in Wei unit. And 1 with 18 zeros of Wei is equal to 1 Ethereum. You'll also see a lot of transactions with the value of 0. These are the transactions that are not transferring any money between people. This is just someone asking a smart contract to run some function. So let's copy this one and see what it is. Okay, this is a big contract. It's an MEV bot, which is perhaps doing some front running or other profitable stuff over the blockchain. And you see it has a lot of money in it. $16,000 in Ethereum directly, and then $11 million in other coins, which are mostly wrapped Ethereum, wrapped Bitcoin, and wrapped Tether dollars. Alright, let's go back to our coding. I think in the next video I will have to tell you how we can extract the data that's in the input field here. For that, you will use a dictionary which is called ABI. Now let's remove this console.log commands. We want to only see the transactions that have a value of more than 1 Ethereum. And 1 Ethereum here in Web3 programming is 1 with 18 zeros in front of it. And in case we find a big transaction like this, we want to send a notification to the console. And also print out the hash code. Here you see we have much less information written to the console, and the reason is that many of the transactions have less value than 1 Ethereum, and they're all filtered out. Let's check this one here. You see it's pending, and yeah, the value is 25.7 Ethereums, which means our filtering is working well. Now let's check this error. This is probably because of the limit of our node, which was 25 requests per second. We were sending a lot of requests. For each transaction that we receive, we are sending a request and getting the transaction information. To avoid this kind of error, I will write a small function that will work as a time delay. So this function gets the delay as input, which is in milliseconds or 100th of a second. And we put the initial time in time 1. And then until the current time becomes bigger than time 1 plus the delay, we stay in the loop. So time 2 is updated on every loop and then compared to time 1 plus delay. And unless it's bigger than that, we will not stop the loop. Now we want to call this function right after getting the transaction information. We can have another issue that happens from time to time and could be related to the delay between the different nodes. So it could be that we get the hash for one transaction, but the transaction information itself is not still available on the node. To avoid that error, we will return or disregard the transaction if what we get from the getTransaction function is empty or null. Alright, so now it runs fine. We can add more conditions here and more processing on the data. As an example, let's find the Uniswap router address. What I want to find is the transactions that are pointed towards the Uniswap router, which means it's probably a token swap transaction. So to do that, we check the transaction to field, and if it's equal to Uniswap router address, then we just lag it to the console for now. Well, swapping here in blockchain means giving one token and getting back a native token or another token of the network. Or the vice versa, you could send a native token which could be Ethereum or wrapped Ethereum and then get a token instead of it. Another thing that we must do and we must always be careful with is to put all addresses into lowercase before comparing them. The reason is that in some cases the addresses can have lowercase and uppercase letters together, and in some cases they're all in lowercase. So just to be sure with our comparison, we put all of them in lowercase. So I've got the wrong address, and what we wanted to put here is the router address. Now let's check again. Okay, good. We found a transaction here. The last two are the big transactions, but the first one is a swap transaction. Let's check it. Okay, it's not mined yet. You can see that. So we found a transaction that's been waiting for being mined since 12 days ago. And why has it been waiting so long? Let's see. Here you see the reason. The reason is that the person who sent this transaction put the gas fee to only 1 GUI, which is very low for the current network. Now let's run the code again and wait for another one. Here we have big transactions but not a swap transaction yet. Okay, we got one. And we got the same error again. I'll change the 50 milliseconds delay again later. This one is also waiting since 5 days ago, but anyway, here we see the to address, so we correctly found a transaction that's pointed to Uniswap router. And checking the Uniswap router contract, we see that it has already 5 million transactions, which means it's really a famous router contract. Here, if you check one of these transactions, you see this one is sending some Cho token to Uniswap router, and the router has sent back some Tether dollars. And for the gas price, you see this one is paying 9.1. Now you understand well why the other one was not mined after 12 days. There are transactions who pay around 9 GUI per gas, and the miners always pick them over the ones that are willing to pay only 1 GUI. So here we learned how to connect to a WebSocket, get the subscription data, then they check the transaction information and do very small processing on it. Next time will be more complicated. Alright, see you next time.